Welcome to Bug Busters Pest Pulse, where we delve into the intricate and fascinating world of insects and their ecosystems. Today, we tackle a question that has puzzled entomologists and nature enthusiasts alike. Can a bee colony survive without its queen? This episode promises to be an enthralling exploration of the life and death dynamics within a bee colony, starting with the central figure of this buzzing community, the queen bee. Known as the heart and soul of the hive, the queen plays a pivotal role in the colony's survival and prosperity. But what happens when she is no longer there to lead? The queen bee is more than just a monarch. She is the lifeline of the colony. Her presence is vital to maintaining the social structure and harmony within the hive. Through her unique pheromones, she communicates with worker bees, ensuring that the hive functions smoothly. Her primary role is to lay eggs, producing the next generation of bees that will sustain the colony. In fact, a healthy queen can lay up to 2,000 eggs per day. This prolific reproductive capability is crucial for replacing aging worker bees and maintaining a robust population. Without her, the future of the colony hangs in the balance, leading to chaos and potential collapse. Understanding the queen's significance offers insight into the broader topic of our episode as we explore the implications of her absence on the survival of the bee colony. As we navigate through this episode of Bug Busters Pest Pulse, we'll uncover the ripple effects that the death or loss of a queen bee can have on her colony. We'll examine the roles of the worker bees and the potential for foreign invasions when a hive is in distress. You'll learn about the desperate measures a colony might take to survive and how these efforts can sometimes lead to evolutionary dead ends. By the end of our journey, you will have a comprehensive understanding of the intricate balance within a bee colony and the critical importance of its queen. Did you know that in the absence of a queen, some worker bees can develop the ability to lay eggs, although they can only produce drones? Stay tuned as we dive deeper into the captivating world of bees and their incredible survival strategies. Within the complex hierarchy of a bee colony, the queen bee holds the most pivotal role. Her presence and influence are instrumental in ensuring the productivity and order of the entire colony, largely through the release of pheromones. These chemical signals are not only a means of communication, but also serve as a powerful tool to maintain the colony's social structure. By emitting specific pheromones, the queen can regulate the behavior of worker bees, ensuring that they remain focused on their duties, such as foraging for food and caring for the larvae. This invisible yet highly effective form of control ensures that each bee knows its role within the hive, fostering an environment of cooperation and efficiency. The pheromones essentially bind the colony together, creating a unified organism that works seamlessly towards common goals. Without these signals, the delicate balance of the hive would quickly unravel, leading to chaos and disarray. Beyond maintaining order, the queen bee plays a crucial role in the overall health and stability of the colony. As the sole reproductive figure, she is responsible for laying thousands of eggs that ensure the colony's continuity and growth. The genetic diversity she provides through her mating with multiple drones is essential for the colony's resilience against diseases and environmental changes. Her presence is a constant reassurance to the worker bees, allowing them to focus on their tasks with the confidence that the colony's future is secure. Furthermore, the queen's ability to selectively lay eggs that will become either workers or future queens gives her a strategic role in managing the colony's population dynamics. This control over the colony's demographics is vital for adapting to changing conditions and threats, ensuring that the bee colony remains robust and capable of surviving challenges. The queen's overall influence extends far beyond her physical presence, as she embodies the colony's strength, unity, and potential for survival. The death of a queen bee initiates a dramatic and immediate transformation within the colony, akin to a monarchy suddenly losing its sovereign. The absence of her guiding pheromones plunges the hive into a state of anarchy. Without the queen's chemical signals to maintain order and cohesion, the social structure of the colony collapses almost instantly. The worker bees, which are typically united in their efforts to support the hive, become directionless and confused. This confusion leads to a breakdown in communication and cooperation, as individual bees start acting in self-interest rather than for the collective good. The once harmonious hum of a thriving colony gives way to a chaotic buzz of disarray, as the bees struggle to navigate their roles without the queen's unifying presence. In this newly anarchic environment, the lack of pheromones from the queen results in significant behavioral changes among the worker bees. Traditionally, these bees are dedicated to maintaining the hive's operations, from brood care to foraging. However, in the absence of the queen's pheromones, they become increasingly self-serving. The previously well-organized division of labor begins to crumble as bees start neglecting their essential duties. Foraging may decrease, leading to a shortage of food, while care for the developing brood may be abandoned altogether. This negligence exacerbates the colony's decline, as the hive cannot sustain itself without a steady supply of food and the nurturing of the next generation of bees. The once synchronized efforts of the worker bees become fragmented, further propelling the colony toward inevitable collapse. This shift underscores the critical role of the queen's pheromones in maintaining not only order but also the very survival of the bee colony. Without the stabilizing presence of a queen bee, a colony becomes increasingly vulnerable to external threats, one of the most significant being invasions by foreign bees. A queenless colony is like a fortress without its commander, lacking the cohesion and defense mechanisms necessary to repel intruders. The absence of the queen's pheromones, which maintain order and signal the colony's readiness to defend against outsiders, leaves the hive susceptible to attacks. Foreign bees, often driven by the instinct to expand their own territories or to exploit the resources of a weakened colony, are more likely to invade a hive that is in disarray. These invaders can quickly assert dominance, taking advantage of the confusion to plunder resources such as food stores, and even attempt to assimilate the workers into their own ranks. This scenario not only poses a direct threat to the existing bee population, but also undermines the long-term viability of the hive. Moreover, the breakdown in the colony structure creates an environment where diseases can spread rapidly, further contributing to its collapse. The orderly operations that once ensured hygiene and health within the hive become neglected as worker bees fail to perform their duties effectively. Without the queen to guide them, there is often a lack of coordination in cleaning efforts, which can lead to the accumulation of waste and the spread of pathogens. The weakened immune defenses make the colony a prime target for diseases that can decimate bee populations. Additionally, the stress of foreign invasions further compromises the bee's ability to fend off infections, creating a vicious cycle of decline. The rapid spread of disease acts as a silent invader, compounding the external threats and accelerating the demise of the once thriving colony. This blend of internal chaos and external pressures highlights the critical role of the queen in safeguarding the integrity and survival of the bee community. In the absence of a queen, bee colonies often resort to desperate measures to ensure their survival, which can lead to unintended evolutionary dead ends. One of the most striking behaviors observed in queenless colonies is the rapid and indiscriminate mating behaviors exhibited by worker bees. Without the queen's pheromones to suppress their reproductive instincts, some worker bees begin to lay unfertilized eggs, which only develop into drones or male bees, and this shift in reproductive behavior is a last-ditch effort to perpetuate the colony's genetic material. However, since drones do not contribute to essential tasks like foraging or brood care, the overproduction of male bees can exacerbate the colony's decline rather than alleviate it. The energy and resources that would otherwise support a balanced population of worker bees are instead diverted towards raising an unsustainable number of drones, which do not aid in the day-to-day survival of the hive. This desperate reproductive strategy leads to an evolutionary cul-de-sac where the colony cannot sustain itself in the long term. The lack of a new queen means that there is no potential for renewal or growth, and the colony's genetic diversity dwindles. Over time, the hive becomes increasingly vulnerable to environmental pressures and external threats as it lacks the robust workforce needed to maintain its infrastructure and defense. This evolutionary dead end is further compounded by the inability to produce new queens that could potentially rescue the colony's lineage. The absence of a viable reproductive strategy ultimately seals the fate of the colony, as it is unable to adapt or recover from its dwindling numbers. This scenario underscores the crucial role that a queen plays, not only in maintaining the immediate health and stability of a bee colony, but also in ensuring its long-term evolutionary success and resilience. In the aftermath of losing their queen, Some bee colonies engage in remarkable attempts to survive, showcasing the resilience and adaptability of these complex communities. One of the most notable strategies involves worker bees attempting to create a new queen from the existing female larvae. This process, known as emergency queen rearing, involves selecting larvae that are young enough to be developed into queens. The worker bees then modify these larvae's diet, feeding them royal jelly in larger quantities, which triggers the physiological changes necessary to develop a queen. This emergency response is a testament to the colony's instinctual drive to restore its social structure and ensure its continuation. However, the success of this strategy is contingent upon several factors, including the availability of suitable larvae and the colony's ability to sustain the demanding conditions required for raising a new queen. In some cases, when creating a new queen is not viable, worker bees may choose another drastic measure, abandoning their original hive to join other colonies that still have a queen. This behavior, known as colony drift, highlights the adaptability of bees in dire circumstances. By integrating into a new community, these bees can continue to contribute to the survival of their species, albeit in a different social structure. This migration can bolster the workforce of the receiving colony, potentially enhancing its productivity and resilience. However, it also raises the risk of spreading diseases and parasites, as the incoming bees may carry pathogens from their weakened original hive. This dynamic underscores the intricate balance between survival instincts and the broader ecological implications of such movements. These attempts at survival reflect the complex decision-making processes within bee colonies, demonstrating their remarkable ability to adapt to challenging conditions even in the face of seemingly insurmountable odds. Certain bee species display varying levels of vulnerability to parasitic invasions, a threat that becomes more pronounced in the absence of a queen. Parasitic bees, such as the cuckoo bees, exploit the weakened state of a queenless colony, infiltrating the hive to lay their eggs. These parasitic larvae, once hatched, can outcompete the host bee larvae for resources, ultimately leading to the decline of the native bee population within the hive. The susceptibility of a bee colony to such invasions often hinges on specific traits and behaviors inherent to the species. For example, species that rely heavily on a single queen for cohesion and order are typically more susceptible to parasitic exploitation than those with more flexible social structures. The vulnerability of different bee species also varies significantly based on their nesting habits. Ground nesting bees, for instance, may be more exposed to parasites that thrive in soil environments, whereas cavity nesting species might face different parasitic threats related to their specific nesting sites. The architectural structure of a hive can influence the ease with which parasites can invade and establish themselves. Some species possess more robust defensive behaviors and structural barriers that deter parasitic intrusions, while others might lack the necessary adaptations to effectively ward off these threats. Understanding these vulnerabilities is crucial, not only for the conservation of individual species, but also for maintaining the overall health of ecosystems that depend on pollinators. This knowledge helps inform strategies to protect bee populations, ensuring they remain resilient against parasitic threats that could otherwise decimate colonies and disrupt ecological balance. The potential for parasitic bee invasions to target queens poses profound implications for the survival of bee colonies and could contribute significantly to global bee population declines. If parasitic bees were to specifically target queens, the result could be catastrophic, as the queen's removal or incapacitation would lead to rapid disintegration of the colony. This targeted attack would disrupt the core reproductive and social structure of the hive, leading to a failure in maintaining population numbers and rendering the colony unable to recover or sustain itself. The loss of queen bees on a large scale could trigger a domino effect, where the collapse of individual colonies contributes to a broader decline in bee populations, thereby threatening the ecosystems that rely on these pollinators for plant reproduction and biodiversity. Speculating on the broader impact of such invasions, it becomes clear that parasitic threats could exacerbate the already troubling decline in global bee populations, with many bee species already facing challenges from habitat loss, pesticide exposure, and climate change. The added pressure from parasitic invasions could push some populations to the brink. The decline in bee populations would not only affect natural ecosystems, but also have severe repercussions for agriculture, as bees play a critical role in pollinating a wide array of crops. The potential for parasitic invasions to expedite these declines underscores the urgent need for comprehensive conservation strategies that address multiple threats simultaneously. By understanding and mitigating the risk of parasitic invasions, efforts can be made to protect bee populations, and by extension, the vital ecological and agricultural systems they support. As we conclude this enlightening episode of Bug Busters Pest Pulse, it's essential to reflect on the indispensable role of the queen bee in the survival and prosperity of a bee colony. The queen bee, with her unique ability to maintain order and facilitate communication through pheromones, stands at the heart of the hive's intricate social structure. Her presence ensures not only the continuation of the colony through reproduction, but also the harmony necessary for daily operations such as foraging, defense, and brood care. Without her, the hive would quickly descend into chaos, unable to sustain itself against the challenges of the environment and threats from invaders. By understanding the queen's pivotal contributions, we gain insight into the delicate balance that sustains bee colonies, reminding us of the profound interconnectedness that characterizes these fascinating communities. This episode also underscores the importance of understanding these dynamics for global bee conservation efforts. With bee populations facing unprecedented threats from habitat loss, climate change, and parasitic invasions, recognizing the queen bee's critical role becomes even more vital. Through this understanding, we can develop more effective conservation strategies aimed at protecting and preserving these essential pollinators. Bees are not just vital for their honey production. They are key players in our ecosystems, responsible for pollinating the crops that feed us. By fostering a deeper appreciation and knowledge of their world, we not only contribute to their survival, but also safeguard the biodiversity that enriches our planet. Thank you for joining us on this journey through the hive. Your support and curiosity drive our mission to explore and share the wonders of the insect world. Remember, as we part ways today, that every bee, no matter how small, plays a significant role in the tapestry of life. Let this thought inspire and guide your actions in nurturing the natural world around us.